All right, we got to finish up Rutherford. We have to take a look at his second two conclusions, the other conclusions as to that he drew from his experiment. Now, I'm just going to back up just real quick. Maybe not. We're trying to back up. I just want to take a look at the previous slide just real quick. His whole experiment, he shot positively charged alpha particles at gold foil. Almost all of them went right through to make flashes on a phosphorus screen. Only 1 out of 10,000 actually ricocheted off. Some ricocheted like almost straight back, but only 1 out of 10,000 ended up ricocheting off. Okay, first conclusion we already covered. Atoms have a small positively charged nucleus. Second one, atoms have electrons that orbit at a great distance. Now it's the great distance that I want to go ahead and take a look at. How did we know that it was a great distance between the nucleus and the outside, the electrons? Well, once again, it has to do with the alpha particles and the alpha particles getting through. Here's a nice little alpha particle right here. Let's say we have an atom, a nucleus right here that's positively charged. Well, if the electron is orbiting really, really close, the next nucleus is going to be right about here with its electron moving really, really close. And then the next nucleus will be right about here with this electron moving really, really close. Well, once again, that's not going to give a whole lot of room for the alpha particle to get through. These atoms are going to be much, much closer together. But if we have, I'm just going to say, here's our nucleus right there. If the electron is orbiting at a great distance, there's an orbital right there, the next nucleus is going to be way down here with its electron orbiting once again at a great distance. Well, that leaves plenty of room to get an alpha particle through. Now, this is just amazing. It's amazing how God made these things, because in real life, if the nucleus was the size of a dime, and this is all the atoms in your body, if the nucleus was the size of a dime and you put it in the middle of a football field, the electrons would be running around in the stands of the football field. That's just how amazing he made atoms, that the nucleus is so small and the electrons are so far away, but yet everything that we touch and feel looks very, very solid. Of course, other than liquids and gases, but you get the point. Okay? Now, his third conclusion is fairly simple. It's just based on the other two. He's basically saying, well, what's in between here? And the answer is empty space. Atoms are made of mostly empty space. We are made of atom. Kind of scary, but we are made of mostly empty space. Okay, and we talk about students in class. Take a student that weighs 150 pounds. Well, what if we could take all the empty space out of the student? He or she would look exactly the same. They would be smaller than a grain of sand, but they would still be a 150-pound grain of sand. They would be super, super dense. Okay, so that was Rutherford. What do you have to pick up? You have to understand what three conclusions did he come up with based on his experiment, and be able to explain why he proved each of those. How did he explain that they're small, positive, and that the electrons orbit at a great distance? And make sure you understand why atoms, or how he figured out that atoms are made of mostly empty space. I think only God can explain why he made it that way, but that's just amazing that we're following in his footsteps. All right, good. Next time we'll come back, we are going to talk about Niels Bohr, and then we're going to move on to the electron cloud model.